Hi, this is Blanca Gutiérrez, Communication Manager of the IMDEA Software Institute, and I'm here today to interview some of the authors of Sleepy Channels, Bitcoin-compatible Bi-directional Payment Channels without Watchtowers. Let me introduce you to Pedro Moreno-Sánchez, Assistant Research Professor at the IMDEA Software Institute. Pedro's main research interest lies in the areas of distributed ledgers, privacy-enhancing technologies, and applied cryptography. Lukas Aumayr is a PhD student in the Security and Privacy Group at TU Wien, working with Mateo Maffei. His research is focused on designing and analyzing distributed protocols, in particular in the context of blockchains. Lukas has previously worked on approaches towards blockchain scalability and interoperability, including payment channels, networks, and cross-chain communication. Aravind is a postdoc at the C Lab group at Carnegie Mellon University, working with Elaine Shi. His main area of interest is on enhancing security and privacy in applications using cryptographic tools and techniques. He has worked on many problems related to the security of blockchains and cryptocurrencies. Thank you all for being here, and we have to say that we have to excuse Mateo Maffei and Giulio Malavolta that couldn't make it here today. First of all, how did this collaboration start?
This collaboration actually started as a nice synergy of the background and expertise that both Lukas and Aravind have. So before this project, we were working with Lukas in many projects in where the goal was to improve the security and the communication overhead of protocols, like the payment channel networks, the Lightning networks, that they will talk later more about it. And Aravind had a similar goal to improve also communication and the security of protocols, but we're looking at from another point of view, that was the cryptography. So we're looking at the cryptographic core details and try to make them more lightweight and more efficient and more suitable for fast and current payments as we have today. So as they had more or less the same goal, we thought, okay, so why don't we put them together and have joined their forces and have a bigger project with a more ambitious goal in which both of them can work together and trying to solve it. And this is how it started.
Okay, great, perfect. And now let's talk about the core subject. What is Sleepy Channels? Lukas, could you answer this question first, please?
Sure, yeah. So Sleepy Channels is a new layer 2 protocol for cryptocurrencies. And the layer 2 protocol means that it is a protocol that runs on top of a blockchain, which is the layer 1, with the purpose of increasing the transaction throughput. So what we did in Sleepy Channels is, for the first time, we managed to achieve actually to have bidirectional payment channels that support an unlimited number of payments, but where the users don't need to stay online and constantly monitor the blockchain. And further, we also managed to reduce kind of the scripting requirements for the underlying blockchain, which makes the protocol itself more compatible with a larger number of cryptocurrencies.
Mm-hmm. Okay. And where can we use Sleepy Channels exactly?
So Lukas hinted to, we reduced the reliance on special scripts. So that essentially means that the Sleepy Channels protocol can be used in currencies that use blockchains, which does not necessarily have a special scripting feature. So all we require is a digital signature authentication. And that's like the most minimal form of cryptographic authentication that we would require for a payment to go through. So any chain that you have, or any currency based on a blockchain that you may have, that requires this layer 2 scalability support, we can essentially plug in Sleepy Channels, and it has its benefits in those chains as well.
Okay then, and diving into the paper, we have noticed that you have observed problems with current blockchains such as Bitcoin. What are those problems exactly? How are they currently addressed, and what are the limitations of the current solutions?
Yeah, it is true. So decentralized cryptocurrencies such as Bitcoin, they suffer inherently from scalability issues. So what this means is, for instance, in Bitcoin, blockchain is technically limited to only handle tens of transactions per second, which is not a lot if we consider, for instance, more centralized like credit card networks that can handle tens of thousands of transactions per second. So there's actually been going a lot of research on how to address this issue with many different solution approaches. One of the most prominent and perhaps also the most widely used solutions in practice is payment channels. For instance, there's the Lightning Network, which has a lot of users. One of the main drawbacks with this approach is this online requirement, which I already hinted in the beginning to. And this means that the users really need to be online and constantly monitor the blockchain. So in other words, if I am a user of this network and I turn off my computer, then I'm potentially at risk already. And this is a requirement that is also not present in the layer 1, so in the cryptocurrencies itself.
Interesting. So what data have you analyzed to detect the problem that led you to develop this solution?
This problem has two layers or two point of data that we should look at. So one is this layer 1 or this famous blockchain, which is basically a distributed database where we could, and it's publicly available. And we downloaded this data, we explored it, and this gave us a lot of information like how these channels that have been mentioned are structured, how the transactions look like, how often they are created, how often they are closed, and this kind of information. And the second point of data that we are using is what they both Lukas and Aravind are mentioning as layer 2. It's this one example is this Lightning Network. And here the data looks more like a graph where it's publicly available, so we could also download it. And basically in the graph, we have the nodes, which are the different users that are using this system. And we also have access to the edges, to the channels that they are mentioning between the different users. And with this topology, we have information as who is connected to whom, what are the possible routes that these payments can take. However, this information is somewhat limited. For example, we don't have access to what are the actual payments being happening or how often they happen. So in this layer 2, there is more privacy in that sense. So the amount of data that we have is limited, but still from it, we can gather some information that is useful for the project that we are using it.
Mm-hmm. And why are users safe to go online in sleepy channels? Is that an advantage of the proper sleepy channels? I think you have already answered this question, but maybe Lukas, you can answer a little bit more in depth.
Sure. So the thing is that in current solutions, users have a limited time frame where they're able to react to a dispute, right? So for instance, let's say there's an outdated settlement of a payment channel that appears on the blockchain. Then the other user has a limited time to react and say, okay, this is not the most recent one. So this is also the reason why they need to be constantly online and check for this. So we actually designed sleepy channels with this in mind and tried to get rid of it. And for us, we don't have this limited time window where the users need to react. Instead, the users can settle a potential dispute at a predefined point in time in the future. And this is also the reason why they don't need to be online constantly. And this is the main advantage of sleepy channels, although it's not the only advantage.
So wrapping up, you have developed the first bi-directional payment channel protocol without Watchtowers that supports an unbounded number of payments and does not require parties to be persistently online. Great news. So congratulations to all of the authors of the paper. And one last question. Are they going to be future directions for sleepy channels?
Right. So we are already exploring some open questions that are interesting in the context of sleepy channels. This stems from the fact that the currently used bidirectional channels, like Lukas mentioned, the Lightning Network, already gives rise to some applications that you can build on top of these channels in the Lightning Network, like payment channel networks, coin swaps, virtual channels, and so on. Now, it's not quite straightforward how you would do that with sleepy channels because we don't rely on users being persistently online. So our dispute mechanism, as Lukas pointed out, is different from what Lightning does. So it is already interesting to see how the dispute mechanism can be used to further build the same applications that you could do on top of Lightning channels. And also, now that you don't have this persistent online assumption, it's always interesting to see what more can you do. Maybe there is things that you can do much beyond what Lightning Network would give you. So these are the problems that we are looking at. And yeah, hopefully we get some good results.
Okay then. Thanks to all of you for this interview.